What we've got is we are required to inspect our reactor head every outage. And in doing so, we had a lot of issues early on with our processes. We have to bring in a robot, and that device then has to do a very sophisticated inspection of the volume of our nozzles and the material that's just behind the nozzles. So what we ended up doing was, for the first few years we struggled. We had a device that would only basically go in and out. It was retracted when we had to put it up into the area of interest. It would expand, and it had some flexibility, but very little flexibility. As we worked through the processes and improved our processes, we ended up getting the ability for our, instead of just the in and out, we actually got to where the devices could actually pivot in multiple directions. And that was necessary because you've got a lot of machine tapers inside of our device, inside of our nozzles, as well as situations where during the construction you get warpage and stuff caused by welding, putting down large amounts of weld metal to seal off the nozzles, so you end up with a situation where you've got some abnormalities that a straight device that was just going straight up and down could not handle. We got a lot of lift off, but now with this new device it'll actually go up around the bends, if you would, and follow the actual contours that are there. The device itself was very innovative in that we took a technology that was relatively, it's been developed for a long period of time, but we had to shrink it down. So because this is a relatively small area, we had to make sure that we could put all of our transducers in a much smaller area. So in the past they've had very large transducers, well, we had to shrink those down. But I think the most important innovation is the working with the vendors very, very closely to put these things together. You know, we as a customer need to push our vendors, but the vendors need to also push themselves, and I think we saw that in a really good teaming situation